Hello again, this is another video for digital signaling and electronics. In this video we're going to discuss the concept of hysteresis. Now this is probably easily explained through an example. So let's say you have a street here and you're walking to school one day and there's traffic, so you choose to cross the street at this point when there's a low amount of traffic and you can cross there. But when you're coming home from school, obviously the traffic is different and you choose to cross here. So what you've done is you've taken two different routes to get from A to B due to, your surrounding environment. Now this is essentially what hysteresis is. It's a dependence on the past and present to sort of determine your ways of getting from A to B. Now this can be applied to a digital circuit through, well, let's do another example here. Let's say you have a flip-flop and you have a noisy signal applied to this flip-flop. Now the flip-flop is going to be falsely triggering at each one of these points, and that is extraordinarily undesirable. So you apply a gate called a Schmitt trigger to the flip-flops. Now the Schmitt trigger is a very simple little gate with an op amp, two resistors, an input and an output. Oh, can't see that. There we go. This is the op amp. This is resistor 1, and this is resistor 2. And this is your output, and this is your input. So, what the Schmitt trigger does is it can prevent this problem of noise falsely triggering in the flip-flop by setting two transition levels in the signal, and everything in between will be ignored. Now, the gate will switch voltages when going from high to low, or low to high, at a certain threshold point. So the gate won't switch to high until it hits this maximum here. Similarly, when the gate is going from high to low, it won't switch until it reaches this threshold point. So it essentially eliminates this noise from the system. And this difference between the high and low voltage is your hysteresis. So for example, let me just draw this out, it might make a little bit more sense. We'll say this is voltage B, and this is voltage A. So you'll turn on your system and it'll come up to voltage A, or voltage B, sorry. Now, once it's going back down to low, it won't switch to low until a certain point, and then it will drop down to low. Similarly, when it's increasing to high again, from low to high, it won't switch to high until it reaches a certain point. And this way, any kind of noise in here is completely ignored. And that is hysteresis.